Hello everyone, this is going to be our experiment 10, which is the concentration of an unknown using Beer's law. So in this experiment, you will learn how to carry out dilutions of a solution and gain experience using the dilution equation. Learn how to use a spectrophotometer and use it to determine the absorbance of a Lura-red solution. Understand Beer's law, which relates absorbance to concentration. And review how to prepare a calibration curve and understand how to use it to determine the concentration of an unknown solution. So you saw what we need. We need a Lura-red stock solution. We need pipettes. We need test tubes. And we also need cuvettes. First, we will go ahead and prepare our solutions for the calibration curve. You will be given this handout and we're going to be having 6 solutions prepared for our calibration curve. The first test tube is going to be just the distilled water and we're going to be using that as our blank. And for the second test tube, we're going to be adding 2 milliliters of Lura-red stock solution, which has the molarity 3 into 10 to the negative 5. And for the third test tube, we're going to be adding 4 milliliters of Lura-red, and the fourth one 6 milliliters, fifth one 8 milliliters, and the sixth test tube will have 10 milliliters of Lura-red stock solution. So it would be 0, 2, 4, 6, 8, 10. So that's what we are doing right now, and that's what you are seeing right now. Test tubes are being filled with Lura-red stock solution. So you see that the first one we didn't add anything, 0, 2, 4, 6, 8, 10. So we can see that the volume is increasing. Okay. And then what we're going to do, we are going to get all of the solutions to final volume of 10 milliliters. So the first one, we didn't add any Lura-red stock solution. It's only going to be water. So we're going to be adding 10 milliliters of water to the first one. So 10 milliliters of water to the first one, and we have 2 milliliters of Lura-red in the next one. So how many milliliters of water we need for that? It's going to be 8 milliliters. So the second test tube we will be adding 8 milliliters. The third one would be 6 milliliters. Fourth one would be 4 milliliters of water. Fifth one would be 2 milliliters of water. And then the sixth one, we added 10 milliliters of Lura-red stock solution. And we don't need to add any water to that one. So at the end, we will see all the test tubes will have 10 milliliters of our solutions, and that's going to be our solutions for the calibration curve. So getting it stirred to have a homogeneous solution. If you don't have this equipment to stir, you can also use a glass rod. Do you see that? We can see that the intensity of the color is increasing. The first one just the water, 2, 4, 6, 8, 10. So we can see that the concentration increases, intensity of the color increases because we have more Allura red towards the end. And we are going to find out the amount of Allura red in a Gatorade sample. So that is the purpose of our experiment. So normally Gatorade is going to be little too intense in color for the calibration curve and also for the Beer's law to work, which I will explain in more detail in lab. What is the Beer's law? Basically, we need to keep the absorbance less than 1. So the solutions that we made, their absorbance is going to be less than 1. But the Gatorade that you buy from the store, that's going to be more than 1. It goes about 2.5 or so. Beer's law works well below 1 absorbance. So we have to do a dilution. That's what we are doing right now. Either 1 milliliter you take from the Gatorade and add 9 milliliters of water, or you can take 2 milliliters of your Gatorade and add 8 milliliters of water to make a diluted solution so that it can fall within the range where the Beer's law operates. So that also going to be 10 milliliters. So you can see we made our solutions for the calibration curve, which is from 0 to 10 milliliters of Allura red. 6 solutions for the calibration curve, and then the last one is going to be our unknown, which is from the Gatorade, that we're going to find out the amount of Allura red in Gatorade sample. And these are going to be little cuvettes. These are the ones we are normally using for the spectrophotometer. So to draw the calibration curve, we need first 6 solutions. Once you take your solutions to cuvettes, we're going to go ahead and put it inside the spectrophotometer and read the absorbance. Water would be 0 since we did not have any Allura red in it. And this is our first solution. You just have to put it inside. It's already been calibrated for you at 504 wavelength, which is the maximum absorbance for Allura red solution. And then you take the second cuvette, put it inside the spectrophotometer and read it, absorbance. So you can see that the absorbance increases as the concentration increases, and you're going to write it down. It's very easy to operate the spectrophotometer. You just have to put the cuvette inside and make sure to wipe outside the cuvette to get rid of any dust and dirt outside the cuvette with a Chem wipe, which I will explain during the class, actually when we are doing it. So right now what you are seeing is getting the data, absorbance data for each solution that we made. So since each solution concentration increases, we see that the absorbance increases. That's the last one, 0.774. And right now what we are doing is you are getting the absorbance of the diluted Gatorade sample. Now it is very well below 1, the absorbance 1, right? 0.357 or 3. So the number that you're going to get, which is the diluted Gatorade sample absorbance. You're going to write down that as well. But we are not going to use that for our calibration curve.